So with that, I'd like to introduce our panel. We have Bob Kolasky, Taylor Roberts, and Todd Younkin. What I'm going to do is ask each of them actually to introduce themselves, but doing more of a personal introduction of their careers before their current assignments. So first, I'll ask Bob and then Taylor and Todd to talk about that. And then afterwards, I'm going to dig deeper into what they're doing now. But again, Bob, please.
Hi, everyone. Bob Kolasky. I'm Senior Vice President for Critical Infrastructure at Exiger. I get a chance to talk about that in a second. It's on, but I'm not very good at holding it close to my mouth. So I know a number of you from my past role. I led the National Risk Management Center in the Cybersecurity Infrastructure Security Agency at DHS, and had several jobs before that where I got an opportunity to do a lot of the foundational work that the department did around risk management and applying risk management concepts to help make critical infrastructure more secure and resilient, which then became what are you making critical infrastructure more secure and resilient against? And it turns out that maybe cybersecurity and supply chain security or supply chain issues were certainly part of it, but it really was an all hazards opportunity. And I spent my career there in Homeland Security thinking about kind of all hazards risks and how to build security resilience, work with industry, incentivize things to happen, put in place policy solutions around risk mitigation. I'll probably bring this up before, but at the end of the day, I thought the important part about national security is not just risk management, but to sit down and say, are we reducing risk? And I think we're going to have an opportunity here to talk about, can we reduce the risk in from microelectronics, concentration risk, amongst other things that we have with the current microelectronics situation.
That's perfect. Thank you very much, Bob. Taylor, please, again, before your current assignment, a very interesting career.
Sure. No, Taylor Roberts, currently Director of Global Security Policy at Intel Corporation. It's pretty easy to go to prior experience. I've been at Intel for a little over 2.5 years, so it hasn't been an incredible long time yet. But prior to that, I worked for the Office of Management and Budget. I know there was some comments earlier about OMB. I wasn't on the budget side, so don't hate me too much. I was on the management side, working for the Office of the Federal CIO, who sort of oversaw federal cybersecurity policy, working on FISMA metrics with our DHS CISA colleagues, and trying to elevate the foundational level of federal cybersecurity, working on improving the authorization to operate process, working with our NIST colleagues on 837, the risk management framework, 853, the cybersecurity control set. So those sorts of more academic publications, which kind of came from informed to my previous work before that, which was at the University of Oxford, where I served as a senior researcher at the Global Cybersecurity Capacity Center, sort of trying to elevate the foundational level of cyber capacity across a bunch of different sort of dimensions of cybersecurity across the world. So that was sort of where I come from.
Thank you, Taylor. So Todd, again, your prehistory from where you are today.
Okay, prior to becoming the CEO of the Semiconductor Research Corporation, I was actually educated as a PhD chemist. I was best suited for the oil and gas industry, but it was 1999 and nanotechnology and chips were cool, and I was going to be able to retire by 32. So I moved to Portland, Oregon with my lovely wife, and I put 16 years into Intel, all Metal 4 and below for next-gen chips. It was the most exciting experience anyone could ever imagine. But in about 2013, we had pushed the last atoms together, and we looked down the roadmap and we said, oh crap, we don't know where to go beyond 2D scaling. And the rest of the world thinks that these are marginalized, commoditized approaches, and that innovation's not required, and we're in trouble. So I positioned into a program with DARPA called Electronic Resurgence Initiative, and we ran a pretty big academic initiative as part of MTO's bid there called the Joint University Microelectronics Program, or JUMP. That program's coming to an end this year and is hugely successful if we can graduate it into the next level of commercialization. And the board at SRC said, hey, you did a pretty good job with that. Would you like a bigger stage? Here you go. And so 2 years ago, I took over. I'm upskilling my team. I'm upskilling the country and really excited about this once in a generation opportunity to make things again. So,
Todd, thank you so much. Now we're going to stick with you, Todd, for a minute, which is let's now talk about your corporation, the Semiconductor Research Corporation, and its role within the ecosystem. Please.
Okay, so we're not a household name, but we are America's premier public-private partnership. We're 40 years old today, and the way to think of it is that the icons of the semiconductor industry in the late 70s and 1982 had seen essentially that their labs internal to their company were shutting down, and that they needed to band together and inform the academics on what was meaningful research that needed to be done and meaningful education, and then create the workforce of the future. So over those 40 years, we've invested $2.2 billion in 3,700 research projects, 15,000 students, including Lisa Su, the CEO of AMD. She's not bad. So really what we do is we accelerate or we engage industry and academics to do meaningful, high-risk, high-reward research that moves into the ecosystem, moves into our members, and hopefully gets all those students jobs in the industry. So we work with 3 U.S. government agencies, DARPA, NIST, and NSF. We'd welcome involvement with other agencies. We have 27 companies from U.S. and like-minded nations, about 90 million a year, that touches 2,000 faculty and students and 1,000 scientists and engineers from industry. And then our scorecard is essentially how often are we successful at either figuring out that something is physically impossible and shouldn't be going, shouldn't continue, or moves into a later stage of commercialization for impact to the ecosystem.
So Todd, I'm going to stay with you for a few more seconds as well, which is on the one side, you deal with universities, on the other side with commercial entities, but also with governmental agencies as well. And your output is tangible research, which can then go into commercial production, but also students. Tell me about your decadal plan.
Yeah, so one of the things that we found that people were struggling with was that, they had the ITRS as a roadmap of what to do. And so without that direction, again, in 2013, we realized that roadmap was no longer of any utility. And so without that direction, it's really hard to get people to kind of swim or row, maybe is a better analogy, in the same direction and get the amplifying force that the industry has benefited from for so long. So in 2021, we put out our 2030 decadal plan for semiconductors that illustrates 5 seismic shifts or grand challenges that need to be met in order for the hardware to contribute to the systems of the future. And the thing that I really like about it, apart from the fact that it was made by 150 scientists, so it was a very collaborative, expert-based document, but the thing that I like is that it's out there now and that it's getting good traction, good support. And now we can use that to point people as to where we're going and how projects and efforts align or fit to the broader, more holistic goals that the industry and the nation need us to solve. So,
thanks, Todd. So Taylor, you have actually a very storied sort of academic background, governmental background. Intel, why Intel? What are you doing there?
That's a great question. I mean, this was all, I sort of joined Intel at an incredibly opportune time. It was just before the sort of conversations around the CHIPS Act were beginning to kick up. Yeah. Ultimately, what really drew me to Intel from sort of government and academia perspectives is that the pace of innovation around cybersecurity, and not just around software security, but around hardware, firmware security, they're just challenges that you can't get anywhere else. And Intel, as an organization that is, US-based, leading the way on a lot of these different innovations, is just, one of the best places that I wanted to be. So I joined in January of 2020. Turns out that was a interesting time to join a multinational corporation where you can no longer travel after 2 months. So that was an interesting challenge to sort of navigate. But what I've done since sort of joining is primarily focusing on cybersecurity policy and supply chain risk management. So a lot recently that's entailed the cybersecurity executive order that came out last year, managing and coordinating our response to that. The supply chain executive order that was just prior to that, which sort of will serve as a precursor into a lot of what the CHIPS Act and the implementation of that will look like. And then finally, I did do some parts of the CHIPS Act advocacy as that related to the security side of things. And ultimately, as we continue to move forward, what the implementation of the CHIPS Act will look like and how supply chain resilience and redundancy will play a crucial and critical portion of that is going to be one of my chief tasks going forward.
No, thanks, Taylor. So again, I want to go in two directions here. One is perhaps for the audience, it would be helpful if you could encapsulate what the CHIPS Act is about in the context of today's discussion regarding supply chains. And then maybe later on, we'll talk about measurable security as well. But let's talk about the CHIPS Act, sort of the Reader's Digest version for the audience today.
Sure. Yeah, I'll try not to go into too many legislative details. But essentially, the CHIPS Act, the impetus for this, it started sort of as an anti-China competitiveness act. It has had many iterations. It's actually passed the Senate through the NDAA last NDAA session. Right. And the ultimate purpose is to try to increase the workforce capacity, the manufacturing capacity, and the research and development capacity of semiconductor manufacturing in the United States. So that there was seen due to COVID that there was incredible risk posed to not just advanced microelectronic manufacturing, but also how that relates to other downstream customers of those semiconductor manufacturers, right? Auto industry being a prime example of what happens when we'll call it a miscommunication around expected capacity happens and the downstream implications that can affect everyday consumers. And so I think the government had a real impetus to make a bipartisan push, which is very rare, as I'm sure most of you know, in today's political climate, to try to advance the robustness of our domestic semiconductor supply chains. And that's sort of, that was passed through Congress, I think about a month ago. I don't know if it was an actual month ago. It feels like a month ago, and signed into law 2 weeks ago by the president.
That's great. Thank you. And not only Intel, obviously, but numerous companies across the nation have been supportive of and potentially beneficiaries of the impetus of the CHIPS Act as well.
Yes, I should also say that it's $54 billion was the amount that was.
Oh,
I
yeah,
didn't actually
right.
say the actual amount, but this is just step one. I mean, barely even step one. Ultimately, this is authorizing funding to be able to develop a program that is going to need to evaluate what sorts of criteria are companies going to need to be able to attest to and meet to be the recipients of this funding, right? And this is not just Intel, but global manufacturers of all different types of nodes, from advanced nodes down to different, more even analog components. Right. So that's just something to keep in mind, that the scope and scale of what semiconductor or microelectronics consists of is very broad.
Thank you. That's great. So, Bob, definitely want to hear about Exiger, but also what you bring from all the legacy of the work that you've done on the governmental side and your transition to Exiger, and what I believe is kind of the rigor and the methodology that you've brought into your current domain, please.
Yeah, sure. Thanks, Nitin, for the opportunity. I was thinking one of my goals at work, as I was mentioning at the government, was to reduce risk to what we call national critical functions, and what were the things that are most important that the government should care about, that industry and government work together to produce. It's easy for me to say that I am still contributing to trying to achieve that exact same thing while I'm at Exiger. Exiger is a third-party risk management, supply chain risk management, corporate risk management company. We're about 10 years old. We're one of the companies that I think is in the lead on what was Charles talked about earlier in terms of illuminating supply chains, illuminating where you're getting things from, and bringing data to bear quickly to help support risk-driven business decisions, help the government have more risk awareness, help the government manage risk to their supply chains and overall supply chains. And so it both heartens and disheartens me. From my private sector perspective, it heartens me to hear that only 6% of private sector has good illumination of their supply chains, which means there's 94% of the private sector that is a business opportunity. So I'm heartened by that. I'm disheartened from a perspective that number is not nearly good enough. And I do think in you know what we're trying to do at Exiger, but just in general, like there's a lot more data and information that can be brought to bear to support better decision making, and translating that in a way that you can do the cost benefit analysis from whatever your risk tolerance is and what your incentives are for wherever you sit in the ecosystem of trying to make operations more secure, protect your functions, make sure you have continuity of business is a key element of what we're trying to achieve. Translate that to this panel, and you know, one of the things that anyone who's illuminated a supply chain as it relates to microelectronics or semiconductors will say, there's a lot of risk in that supply chain right now, and you can only illuminate your way out of risk so much, right? At some point, you got to do something to change the fundamental nature of longer term. Will there be less risk in that supply chain? And that's, you know, I'm eager to be part of that conversation. You know, I was a big supporter of the CHIPS and Science Act in terms of sending the message that, you know, from a national security and economic security perspective, it's important to invest, do the kinds of things that Taylor was just talking about in the CHIPS Act, because that's going to ultimately make us more secure as a country and make businesses more likely to thrive in the face of a lot of risk scenarios.
So Bob, let me pick a word you use, a lot of risk. I mean, quantifying risk.
A lot of risk.
Yeah, a lot of risk. So, and I think sort of Taylor started to touch upon it as well, which is that if indeed we do want to take a systematic approach, whether it's one of your clients, meaning an individual company, or as a nation as well, I think you've been thinking quite carefully about the rigor one has to use about labeling things, quantifying risk, and then finding ways to measure and look at whether you have come across the right remedies. So I was wondering if you could talk about that a little bit more.
Yeah, in terms of how I come to think about risk in this context, it is around critical functions and what are the things, and so if ultimately here we're talking about microelectronics, what are the things that microelectronics are most important to from a critical, if we're talking from a national security perspective, economic well-being perspective, can you use that framework? CISA actually published something earlier this week looking at a risk insights piece, looking at quantum computing from that framework, where it's, you know, where adopting the post-quantum encryption standards that NIST is going to put out in 2024, where is that going to be most important across critical infrastructure? And I would say the same thing as you're looking for a risk model to think about the importance of incentivizing where you want to make sure certain chips and microelectronics are available. Think about the places where it's going to contribute most to critical functions. Of course, depending on where you sit, your critical functions are going to be defined in a different way. And then evaluate, you know, going back to evaluate the shock scenarios that would cause, the reason the existing risk is here is because that concentration risk, we perceive there are shock scenarios. We know there are shock scenarios that are going to sit on top of that concentration risk and create real problems. And so how can we diversify? How can we plan against those shock scenarios? What do they look like, whether it's a pandemic, whether it's China aggression on Taiwan, whether it's, you know, change in economic policies in such a way, and do we have scenarios in place, particularly for the things that are most important from a national security perspective, to have the chips we're going to need to maintain
So
national security systems.
Do you or others develop models and then be able to apply these sort of what if or shock scenarios in order to be able to understand what the risks might be and then institute sort of preemptive remedies?
Yeah, I mean, what Exiger does and what we're doing is we're evaluating risk across a number of categories: foreign ownership, operational risk, financial risk, environmental governance, sustainability risk, and sort of quantifying and qualifying how that risk looks like in an individual supply chain for most of our clients. But then in an aggregate, do you have sources of that? And it's through that risk illumination, that characterization of risk that we're doing at Exiger, you can evaluate the question of, do I think I'm taking too much risk? Where are my sources of risk? Where do I do additional due diligence or look at alternatives to mitigate that risk?
Great. No, thank you.
And I won't say risk anymore.
Right. No, well, it's important. So, Todd, I'm going to turn to you for a question, which is that you're at the early stage of innovation, working with universities, funded research, with obviously an intent to turn into commercialization and then be integral to the supply chain. But are there things that you do as an institution, either in terms of education or even actions, to be able to anticipate and therefore, in effect, design for robust or resilient supply chains? Your thoughts?
Yeah, so I'll try to give a concrete example. And I think Huawei and the interest in having a more sustainable communication ecosystem was something that, we could all look around in 2017, 2018 timeframe and see that, in a US sense, we'd missed 5G. So knowing that, with DARPA, we put forth an effort to make a 6G push. It's not rocket science. There's a G every 10 years, so 2030 and 6G is the target. So we put together a scientific team, a multidisciplinary team. It made the hardware. We have a working test bed right now in Dallas, Texas. That's at Samsung, a US ally. Intel and Qorvo are heavily involved in that work. There's a startup company called Pi Radio out of NYU that's actually building small systems and trying to expand that. The challenge is going to be that this is too early for the commercial types to start working on 6G. I mean, they're still trying to sell you 4.5G as a 5G solution. And I've got nowhere to pass it to, right? So my mission is 10 years out. And as we get closer to 2030, I can either follow that work and make sure that it is delivered, or I can stay on target for my audience and my group and keep serving the 10-year time frame. So part of what excites me about the CHIPS Act is the call by Congress and by Commerce to make an accessible chip making facility, an accessible packaging facility or network, and to have somewhere this kind of, it's not university research anymore. We did the university part. We've built demonstrators or prototypes. We have a starting company. We have DoD trying to build individual units. They need to iterate on that. They need to get packaging that's, from a source that's reliable and trusted, maybe onshore. So it's really about passing that work to somewhere to finish it off, which is why I'm really excited that we are a MITRE Semiconductor Alliance member, and we're trying to help MITRE fight for CHIPS Act funding to build an ecosystem and have somewhere that we can pass promising things that are too important to forget about just because they're 5 years away.
Right, yeah. So actually, if I were to give you a time machine on this, which is, let's assume that the one of the institutions which the CHIPS Act is aimed to build is this thing that we call the National Semiconductor Technology Center. So let's assume it's running, it's humming, people are working there. Then the research that you had this sort of the inspiration to initiate on 6G, what would that look like today? You would already have...
It's available today for handoff,
right.
in a sense. And that center was a UC Santa Barbara-led endeavor. I think it was about $50 million in funding over 5 years. But it needs to go to that 5 to 10x level commitment with, dedicated SMEs. Hopefully that's an acronym this audience knows. Yeah. Both small and medium enterprises and subject matter experts. But with dedicated folks, going beyond the demonstrator academic concept and really converting it into the standard, right?
Great, thank you. Yeah. So Taylor, your thoughts? I mean, Intel, a huge corporation, right? So you've got product shipping all the time, and I presume you've got supply chain topics in your existing product line. But then, as you think of your roadmap of products over, next 1, 2, 5, 10 years, your technology roadmaps are amazing. You can do the Moore's law thing. Everything gets smaller, everything gets faster. It's all great. Is there a commensurate sort of view on supply chains, either for your existing product lines and then as you anticipate factors going forward?
Yeah. I mean, look, when it comes to microelectronics supply chain, complexity is the name of the game, right? Because and let's just using Intel as an example, right? As a significant multinational company. Not only are you looking at supply chain risk management as it relates to the different parts of the value chain. Intel is an integrated device manufacturer. Therefore, we're looking at supply chains starting from pre-competitive and R&D, going into manufacturing, going into packaging, going into shipping, right? There is supply chain risk associated with those different parts of the value chain. But also, then you have different products, right? That there's going to be unique supply chain challenges to the different type of product, whether it's a memory product, whether it's a logic product, discrete analog or other product, DAO product. So there are going to be unique, different risks posed to those different types of products. So the complexity, and that doesn't even bring into account metrology and measurements, which we can get into in a little bit more further, because then you're starting to ask the question, okay, well, in my product, sure, I might be able to assess and quantify risk in some sort of discrete way, but why do you need this information? What are you going to do with it? And that was brought up even in the government context, right? So some of those hurdles, some of those cross organizational hurdles exist within companies as well. So ultimately, it's confoundingly complex, and that's just sort of on the logistical side. Doesn't even bring in the software supply chain side of thing, which Intel does have a significant software presence as well, right? So one of the things that when you're starting to sort of look forward on the product roadmap, we look at risks. I mean, if we were to look across the existing value chain, which shouldn't change significantly, even though products may evolve, I wrote down just a few examples of sort of some of the risks that you might see within the different stages. So like inbound materials, you want to look out for non-conforming parts and materials. Make sure you have responsibly sourced minerals. Those are on the sort of pre-manufacturing side. Then you've got on the product development, design and development, you've got things more typical like compromise or stolen secrets, but also things like unintended consequences of intentional design changes, right? And that's something as you look forward, if you're starting to make intentional design changes, what is the impact going to be potentially on previous iterations of that product? Then you go into the actual manufacturing process and you're looking at more conventional risks around network and system vulnerabilities, unauthorized facility access, unauthorized changes to machine settings, et cetera. And finally, when you're looking at the outbound and the finished good and product, you need to be concerned around tampering. You need to be look at concerns around product substitution and counterfeiting, right? And that was brought up in the previous panel as well. So all of these are just different types of risks within the different value chains that Intel is intrinsically aware of and monitoring. We have a compute lifecycle assurance program that we sort of use and embed to sort of look at the build, transfer, operate, and retire part of our supply chains, right? And we have different control measures across those different elements that we try to make sure that we're able to quantify and mitigate as much risk as possible.
Thank you. I'm going to pivot a little bit to the CHIPS Act, and one of the aspects of the semiconductor supply chain, which possibly is the most vulnerable or weak even on a commercial basis, which is to do with packaging. So the ability for the United States to design and produce semiconductors is very good. Most of the packaging technology and packaging production for semiconductors is not in the US, only a small percentage is. So, and therefore, if you're building a chip in the US, you still have to ship it typically offshore and then bring it back. So the question for you, maybe starting with you, Taylor, is how do you deal with that? And indeed, if you have something that you think is trusted, you have provenance, all these things, you're still having to ship it abroad for the packaging and bring it back. So perhaps if you could give us a snapshot of, what's the world looking now? And then with the CHIPS Act, with all these initiatives, particularly the technology evolution of packaging and things that we call heterogeneous integration and so on, how that could be dramatically changed with both the combination of technology, the awareness, but also the funding of the CHIPS Act.
I mean, there's lots of different parts of that conversation.
Yeah.
I'll try to.
I know Todd is about to say things, so Taylor, why don't you go first and then,
So I'll kick off a little bit and we'll start about in the context of the CHIPS Act. Ultimately, CHIPS Act focusing broadly on the manufacturing, R&D, and workforce capacity. Yeah. The funds that are going to be made available through the CHIPS Act are meant to sort of help offset some of the risks, the future risks that are associated with that global geographic supply chain, right? There is, as Bob mentioned a concentration risk in certain regions of the world. Whether that's not just limited to packaging, by the way, that's still in manufacturing of advanced nodes, right? That's just statistically true. What the CHIPS Act is trying to do, that in the event of another shock, whether that be geopolitical, economic, trade, what have you, we don't want to be caught on the back foot again. We want to be able to make sure that we have domestic presence and at least have a sort of, I hate to use the word minimum viable capacity, but something around that to be able to ensure that the United States is able to maintain either, on the one hand, critical defense or critical national functions, and on the other hand, there is a massive commercial need for semiconductors, right? It underpins every technology that is sort of procured in some of the mass market areas. So I think the CHIPS Act has sort of helped on the capacity front. Now I'll actually turn it over to Todd on the packaging piece, because I think you mentioned it a little bit in your previous remarks.
Yeah, please, Todd, why don't you go ahead? And then I do want sort of Bob's perspective on sort of the broader implications, because he's dealing with the whole ICT and systems aspects as well. But Todd, please.
Yeah, I think, as a nation, we're really great capitalists, right? We read the Wall Street Journal and we pursue whatever it tells us is valuable, and we can optimize that like nobody's business, right? And we've been doing that for 30 years.
Yeah.
And we have bought into the narrative that the fastest device and the latest advanced node in a wafer factory is the path. But the entire package system that's sitting here in this Mac on the front row is much more complex than that. And many of you may be shocked to know that packaging is the new king. Apple put two chips side by side and sold it as their latest, greatest thing, and everybody went crazy. But that chip was packaged outside the US, right? The thing that we kind of have going for us is that Congress and commerce, they can shine a bright light on important things, and we actually, before money starts to rain down, already start to position in the ways that they are signaling is important. We're that good at capitalism, right? We will just go nuts. And so I see a lot of hope in reshoring, onshoring, creating new technologies. One of the things that's probably the most exciting element is that line between the traditional packaging facility and the wafer factory is blurring. And so some of the technologies that were used in wafer fabs are now going into packaging, and that's adding value and reducing that sort of commodity low margin mindset, which will help shore things up here.
And that's where a lot of the innovators that you sponsor and fund
That's
are
right.
working on, right? And there's amazing things coming out of the universities to do exactly that sort of vision that you're talking about.
That's true, but think about it the same way. We've said that packaging is not cool, it's not important. Academic grants dried up. Mechanical engineering departments stopped working on that, right? The faculty are in need of a turnover of young faculty in this space, and CapEx investments at our universities. We have essentially 4 or 5 universities in this nation that understand packaging in a meaningful way. So one of the reasons we're really excited about it is about, broadening that network beyond just those 3 or 4 or 5 schools, beyond the faculty that have been doing the good fight for 20, 30 years, getting into students in mechanical engineering and the deans of mechanical engineering to help them understand that this is important, and then pushing that technology into customers like Intel or TSMC in Arizona or Samsung in Austin.
That's great. So Bob, your comments, and maybe this is the last word before we take questions, but again, you deal with systems. You've had the governmental experience, a lot of things that you've done, and then now in the commercial domain. So as both representing systems companies and your own experience, your observations, so open to whatever your comments are. Yeah.
Sure. So I said I wouldn't talk about risk. So I'd like to instead talk about flip side, right? In this a little bit what you're talking about, Todd, opportunity and innovation. And I think, one of the ways you sell this, right, is this is an investment in opportunity and innovation, and should be thought of that way rather than simply trying to claw back to a different situation. So with the funding, with the R&D, with the workforce development, is going to give us more opportunity for that will hopefully have spillover impacts across the ICT industry. We certainly saw in the ICT industry that it there were parts of it that barely survived the pandemic in terms of things not breaking. There are other things that are going to need to be dealt with as ICT companies do business in terms of not enabling slave labor, forced labor, climate impacts, things like that. And so, we've talked about this in terms of having technology available to help make sure we can do critical systems, but can we innovate in a way that has a different impact against the environment? Can we innovate in a way that creates different labor standards across different things, and creates things like that? And that's what's neat about this policy area. You can really touch on all things that I hope government is intended to inspire and then let industry run out and meet some of those objectives. And I hope we realize some of the benefits of that through this process.
That sounds great. Thank you very much. Any questions? Please, go ahead.
Yeah, we have a question from online, actually two, but this one talks about U.S. companies and government agencies. How can they promote the adoption of more security-oriented practices by allies and aligned nations who participate in electronic supply chain? And how should these be approached? Is there supply chain diplomacy? Are there other measures? And then who in the government should take point? Is it State Department, Commerce? What's the involvement of private industry? Any thoughts on that topic?
So Taylor, could I direct that to you, please?
Sure. Talk about some of that, but I also know that DHS is definitely the nexus. Spoiler alert: DHS is the nexus of one of those definitely key government collaborators. But to the overall point around public-private partnership around product security, ultimately it's invaluable. I think a lot of the discussions, particularly when it comes to international, involves around standards development. Ultimately, if we're able to have a common, either common minimum baseline or common international standards that domestic policies are founded upon, you're all working off the same playbook. So, I mean, NIST does a great job around, 800 161 that was published previously, the revision of the cybersecurity framework, which is undergoing right now, which everyone should participate as part of those conversations. The CSF has served as a foundation for so many different nations' approaches to cybersecurity. And so I think making sure that those conversations are had through standards development organizations, domestically and internationally, include ISO, ETSI, and others, is a great start to having those collaborations. Now, in terms of government agencies, it's really going to depend on purview, right? So if we're talking federal agency cybersecurity, CISA has a major role. If we're talking defense, obviously DoD, and the Office of the National Cyber Director has an interesting role, particularly when it comes to the National Cyber Strategy that's under development, right? Each agency sort of has their own individual role to play, but I think that industry should continue to work both collectively and directly with these agencies to make sure that progress is fully realized.
Right, thanks for that. And Bob, did you have a comment on this?
Yeah, a couple thoughts. I mean, one, we certainly do business with companies that do a lot of business in parts of government, in the Five Eyes and in the Quad being Japan, India, Australia, and the U.S., Five Eyes being Australia, New Zealand, England, and Canada, the U.S. I think there was discussion earlier in a number of contexts. I think there has to be an element of course, we are supporting American industry through the work of Congress, but hopefully not at the expense of something that is going to limit our allies' technologies and our allies' development and be so path dependent there. Because I think to reach the sort of international supply chain harmonization, supply chain standards, I do think there's a view that it can't all be about competition between industries from different countries. And companies like Intel obviously do business, are global companies no matter what. And so make sure that there's I like the idea of like-minded countries who are supporting standards to make sure that stuff that's being manufactured is available and secure in the face of duress. We win, so do our allies, hopefully. And I think it has to take that approach again. So.
Great. Yeah, Taylor.
Yeah, just to build on that, I mean, before the Chips, the Chips and Science Act was passed, Europe passed their own Chips Act, right? Which interestingly was started after we had started having our Chips Act discussion. No further questions. So, I mean, there was clearly alignment on the identification of the need and the risk posed to semiconductor supply chains, both within the United States and within Europe. And there are other allied countries as well that are starting to sort of pick up on this, that are in a unique position. Japan, for example, is one of the biggest concentration of chemicals that is supplied into semiconductor manufacturing. And they're starting to see sort of how important their role is and how they can help contribute to making sure that our global supply chains are robust and resilient.
Makes sense. Yeah. The other question, please.
Yes, the other question, it's a subset of this conversation, which is, are you concerned about scrim risks associated with using educational organizations and to do the research and assessments, and how are you mitigating that particular topic?
So let me actually readapt that question because Todd, yeah, I was going to direct this to you because it is about people, and that's what I wanted you to talk about. So Todd, please.
Very concerned on application towards academic settings. Academics are at their best when they're given degrees of freedom, which includes global freedom, and very resistant to restrictions. And I think when you do that, you often essentially don't get the results that you want. So in a sense, you can do it, but you may not generate the right long-term solution. You know, one of the questions I would pose to this audience, which again is a little different than the one I'm normally sitting in, security from our standpoint is more than just software-driven security and blockchain solutions. We've been trying to drive hardware-based security for some time, and there's quite an appetite to increase the investments in hardware-driven security solutions. I think there's a really interesting moment in time now with the packaging becoming more of the solution that chiplets may offer a path where maybe just a few short years ago, you would have had to have that security solution into your latest and greatest full chip solution, and it wasn't going to be cost effective or it wasn't going to be a general solution. But now, because of a chiplet strategy, you might be able to have, for the Department of Defense, a small adjacent chip solution for security that meets your needs without passing it on to the entire ecosystem. So there's an interesting moment in time here in hardware-driven security to be a part of the solution, but we don't have all the answers.
Thank you. That was great. So I'm just going to do a quick wrap. We're almost out of time, but this topic of measurable security that Todd you touched upon, I know Tyler, that's something, Taylor, that's of interest to you as well. And it is an area which is integral to the whole supply chain. Quick thoughts on that?
I mean, ultimately, there's a lot of good work going on in the public-private sector around what they call MQA, measurable and quantifiable assurance. That's something that we're really trying to get a better understanding of what type of information is needed in order to be able to provide that transparency and that validation and verification that's necessary. I do think, again, to reiterate Todd's point around hardware-enabled security, I mean, there is some, Intel has a capability, Intel Software Guard, software extensions, SGX, that enables verification and validation of cryptographic modules outside of the operating system. So you're using hardware to essentially do that validation without ever having to engage the operating system, eliminating a whole host of potential vulnerabilities that are associated with going through the OS, right? And that's something that you can do verification and validation of from an ongoing basis. So these sorts of different criteria around hardware security, I think, should be included when it comes to considering how are we considering CHIPS Act funding going forward, right? We want to make sure that whoever is going to be the recipient of federal funding takes security seriously.
Great. Thanks.
If I might add a point to
Todd.
that, we talked about the 10-year plan. We had
Right.
5 grand challenges, and one of them is ICT security driven by hardware security solutions. So
Absolutely.
we've tried to make it as loud and clear that that's an important part of a holistic solution. But hardware security is a hard one because traditionally folks have not been compensated for security solutions, so they don't invest in it. I mean, I'll be honest. And then second, do you want the academics publishing the results that they get from those findings? That's a complicated question, but that's their incentive space. So if you can't provide that incentive for them, you need to find ways to incentivize them via other channels.
So you touched upon a number of things very much related to something that's also integral to the CHIPS Act, which is workforce development, the right motives, the right training, the right source of skills and capabilities for the nation. So with that, I think we're pretty much out of time. I'd like to thank the audience for joining us and the panel. Thank you so much. Bob, Taylor, Todd, this is a pleasure.